Hello, I'm Joshua Roback, Principal Security Solution Architect at Swimlane. And today I'm going to talk about MCP, or the Model Context Protocol, and how it can be used within Swimlane Turbine. MCP is a protocol used by AI agents to be able to understand which tools they have available to them in order to execute on the task that the agent was given. Here in Swimlane Turbine, you can see I have an agent action added to my canvas with the goal of an agentic IOC analysis. If you take a look at the configure page, you'll see I have 3 MCP servers that are set up to be used by this agent. 1, VirusTotal, 2, Slack, and 3, Firecrawl. In addition to the MCP servers, we give the agent a task in the form of a prompt. In this really simple example, you see I have given the agent the task to check the reputation of a domain, and then if it is not benign, notify the Slack channel. Give it a summary of the details, include a breakdown of the verdicts, and then an additional task of sending another message to the Slack channel, asking for approval to block the domain on the firewall, and then giving it a link to providing the message to facilitate the approval workflow, which is also a Swimlane playbook. In the message, instruct the user to click the link to automatically block the domain on the firewall. Now, as you can see, there is variables injected in this prompt. So when running this within Swimlane Turbine, every execution of this agent is going to have context of the specific task and the specific maybe security case that's being worked. Let's see the outcome. As you can see here, I received the Slack message successfully, showing both messages. The first being the summary of the enrichment outcome from VirusTotal with some AI chosen important details, and the secondary message asking for approval to perform the block. So upon running the agent, it was given the following results. And it does so with transparency. So it provides the steps that it took to handle the task. So first, it did reputation analysis. It retrieved the reputation report of the domain that it was given and found a negative reputation with this analysis. And it did in fact summarize the results as I expected. It then, given these results, made the choice to select the Slack channel that it was going to run. Now, the Slack API and the Slack MCP server does not take the channel name as direct input to send a message. So first, the channel name has to be resolved into a channel ID. And the AI agent was able to recognize this, even though I did not say so directly in the prompt, and go ahead and resolve that channel name into a channel ID. Then it sent the first message, and it describes what type of message it sent, which is what I asked for. And then it sent the secondary message, again, doing what I asked for, including a link for automatic blocking. And then this is really interesting. So it had given the severity of the findings, it attempted to add an additional reaction to the message in order to emphasize for the receiver. And you can see it attempted to add it, but it failed due to error. Well, that's because the MCP server did not support this capability. However, even though there was a decision to make, which was a good decision to make, add emphasis to the message, and it failed, that did not mean the entire playbook or the agent's work failed. It was still able to go through the necessary steps and identified that the necessary actions have been executed as requested. And I can confirm as the recipient that we did receive the message with the appropriate secondary message and link. So this demonstrates how agentic AI using MCP can allow an AI agent within an automation playbook to take action using tools. Thank you very much for watching. If you liked this video and want to see more, please head over to swimlane.com.